Hey guys, welcome back to Technicos. Today we are going to understand pods, and before moving forward, I want to tell you that we have already created the first part of the Kubernetes master series, which is Introduction to Kubernetes and Architecture. It is recommended for you to watch that before heading to the second part. So we are going to understand what are pods in Kubernetes. If you are very new to Kubernetes, this is going to be slightly difficult to understand, but if you stick with me till the end, I can guarantee you will understand this concept easily. So what is a pod? For the definition purpose, I'm telling you, a pod is the smallest deployable unit in Kubernetes. Okay, a pod is the smallest deployable unit in Kubernetes. So why do we even care about pods? Okay, so in the previous lecture, we have seen the architecture that we have a master node, we have a worker node. Okay, in Kubernetes, node is nothing but the machine. Inside that, in the worker node, mainly we are going to focus on the worker node. So in the worker node, we have something called as pods. Okay, so we are going to understand what are these pods and what are the importance of these pods in Kubernetes. So they do exist in Kubernetes because Kubernetes never directly deploy your container. Okay, what it does, it deploys inside a pod, an object called pod. So this is your application container, application container. It is running inside something called as pod. Okay, why it does this, you will understand. And this application container is your application which you have built, though it is some banking application or some project that you have worked on. So you are going to put this in some registry, for example Docker Hub, and Kubernetes is going to, so from Docker Hub, Kubernetes is going to pull your image, make one pod, okay, and put it inside the pod and runs your application. This is how it works. So why it does this? So many beginners thinks that Kubernetes directly manages the container. No, it does not happen like that. Kubernetes does not manage containers directly. They manage pods. Why? We will understand. The reason is very simple. The pods exist is because Kubernetes needs one object that can represent the application container, its network, its storage, its restart behavior, its lifecycle. So what I told, that Kubernetes needs some object who can take care of all these things. Its application container, networking, storage, restart behavior, and lifecycle. Why this is important? Because you need someone to be responsible now. You need someone who can responsibly handle your application, which can responsibly handle the container networking, which can responsibly handle your storage, restart behavior, and lifecycle. This lifecycle part, we will get into this after some time. But for application container, you already got my concept that this is a pod, which is an object in Kubernetes, and inside that object, your application container is going to run. So this is the application container, for example. And when I say networking, so for example, it has two containers and the two of them needs to communicate, and for that, Kubernetes allows them to talk with their local IP address so that they can easily communicate. And for example, we also need another container for storage, so we can have it inside the pod. And when I say network and storage, and when I say restart behavior, for example, the pod goes down. Okay, so Kubernetes, what it does, it restarts again another pod with all three configurations. So what I told, that a pod is running container, it has its IP address, it has its storage volume and restart policy and metadata. Okay, so it's going to be taken care by Kubernetes. Now you have understood a smaller picture. Let's understand a bigger picture. Okay, so we have a node, okay, in one cluster, and we have two pods. One pod is running the front-end application, one pod is running the back-end application. In the back-end, we have another container for database, for example AlloyDB. Okay, so this D is AlloyDB database. This is your backend container. This is your front-end container. This is one node. We are talking about node number one. There can be multiple nodes in a cluster. Again, 2 pods or 3 pods based on the node size. Okay, so this is how the whole picture and whole thing is covered under one cluster. Okay, I hope you got the point. So when a pod downs or pod got deleted. So Kubernetes automatically brings up a new pod like this. Why this is happening? Because you have set in your YAML file that we need 3 pods. So it always try to make 3 out of 3 if you have sufficient node memory. So before I go into networking and storage, I want to tell you the pod lifecycle. Okay, this is important because you will be creating pods, and based on that you should be able to understand and figure out what is happening with your pod. Okay, the first stage is pending. Why this is a pending stage? So this is a stage where you will able to understand a pod is accepted by Kubernetes. Okay, accepted by K8s. Okay, but what is the problem here? Why it is still pending? Because the containers are still not running. Containers are still not running. Maybe a scenario where it is trying to pull the image from the container from the Docker hub. Okay, this is the stage. Or node not available. It is possible. I told you that this is a node which I just shared. So if the node is already full, it cannot allocate a pod. So node not available is a scenario. This is one. Number 2, and the number 3 might be resource not available. Okay, resource not available. Once this is done, you will come to a second stage called running. This is the stage where the pod accepted and completed its task successfully. This simply means the pod is running. Then comes the succeeded. The pod completed its task successfully and exited. For example, the pod, let me write this. Okay, the pod completed its task and exited. This is a scenario where you have a backup job or a batch processing job. Okay, so your pod gets into running state and succeeded. A failed is a scenario where the pod is failed due to some error. Okay, failed due to some error. Why this happens? Because it can happen because of many reasons. Okay, maybe your app crashed, maybe image not found. Possible scenario where you have given the image path for Docker Hub, but the image is not there. Okay, so these are possible reasons. Now comes a very rare scenario where you will see error as unknown. So this is a scenario where Kubernetes cannot determine pod state. So it is possible because of some node communication issues. Usually you will see the pending state, running state commonly, or sometimes failed state. You should be, now you can understand what are these stages and what does these mean, so you can able to debug and get your things ready. Now these are some common pod statuses that you should be aware of. Container creating, okay, is a state where the pod is still being prepared. Okay, then crash loop backup. This is a very common, I have faced many times during deployments. So this is where the container crashes repeatedly. Okay, for example, you have a banking container or banking software where you just have it on Docker Hub. You created a resource pod and you pulled that. It is possible the container is being pulled successfully, but it is crashing. Then comes the image pull back off. Kubernetes cannot pull the image. The pulling failed. Now comes terminating. So pod is shutting down is also a common status. Then completed is the task finished successfully. Okay, although I'm introducing you these status because these are very, very common for beginners to face, and I don't want you to get into a loop where you cannot figure out things. Okay, if I'm teaching you something, it is my duty to teach you everything, every small detail, so that you can able to go and deploy your application. Now again, this is very crucial to know the pod networking and pod storage. We need to understand this in depth. Okay, how containers communicating inside a pod. So we can start. Okay, so in Kubernetes, in K8s, remember the statement, every pod gets its own IP address. So this is a statement that you should remember. In Kubernetes, every pod gets its own IP address, and containers inside one pod can communicate using this IP address, which is your pod's IP address. Okay, for example, we have a pod here with 2 containers. The container A is a backend service of a banking application. The container B is AlloyDB database container. Okay, how they are going to communicate? For example, in this backend service, for example, there is a code, okay, which says whenever a new user registers, write down that to the LOIDB. How it is going to know how this backend service is going to know where the LOIDB exists, or does it even exist? So here comes the pod IP. Okay, so we have pod IP. For example, we will select 10.1.1.5. This is the pod IP address. Now, containers inside the pod can communicate using this IP address. So this backend service is running on port 3000. Okay, and the backend service application, because both containers are inside the same pod, they share the same network namespace. When I say same network namespace, means same pod IP, same localhost, same port space. So the second container can directly access the first container using localhost colon 3000, or the first container can directly access using the localhost 4000. For example, this is giving you an example. Okay, LOIDB container does not need to know the pod IP. It can directly communicate using localhost. So this is one of the biggest benefit of having pods and multiple containers running inside of it. But in scenario, this is not an ideal scenario. We can have one pod, we can have another pod, and for example, here we are running backend service with LOIDB. Here in another pod, we are running the frontend service. Now, frontend has to communicate with the backend. How this communication is going to happen? How you are going to create a bridge between them? This is my question. Now you would be thinking, we have pod IP here, we have pod IP here. We will communicate using the pod IP. If you're thinking like this, then you are absolutely correct. Okay, we can technically use the pod IP, but there's a glitch, there's a loophole here. I told you, if two containers are running, they can use localhost, but here they cannot. Okay, because the backend service in a different pod, the frontend service in a different pod. Here they either can use pod IP, but that they cannot use. Why? Pods are ephemeral in nature. What does this term means? That means they are designed as temporary or disposable units that are not meant to survive failures, node crashes, or update. Which means, if I can explain you here, this is one pod with IP address equals to 10.5.5.5. For some reason, this pod gets crashed. Okay, and Kubernetes checks that, hey, we have defined that we need 3 pods, one pod crashed, so it will try to make it 3 by 3. It will create another pod. Okay, for example, there are 3 pods. Okay, and now the pod which crashed and recreated again will have a different IP address, 10.9. So their IP addresses also changed based on their status, whether they are updating themselves, whether they are deleting and recreating. So in these scenarios, their IP address will change. So we cannot directly hardcode the IP address of a pod in the backend service so that they can communicate with the frontend service, because their IP address is going to change. How they are going to communicate? We cannot make a system which takes care of that. So for that scenario, we have something called service. We are going to learn about this service in a upcoming lecture. For now, just understand what it is and how we are utilizing service instead of pod IP, because it is changeable. So we name this frontend as frontend service, something unique, and we name the backend service as backend service. We define a bridge so that these can communicate with their service name. So frontend pod talks to the backend or backend to frontend, not using the pod IP instead of services. Okay, I hope the networking is clear to you. I'm not getting into deep because the service itself is another lecture that I am planning after, I guess, one more lecture, and in that I will explain you in depth. I hope your networking concepts get clear, and now let's move to the storage concept. So we have a pod, we have 2 containers, DB and backend. Okay, so when a container starts, it gets its own file system. Okay, inside the file system, the application can create files, logs, cache the data, or upload images, reports, and many other things. Okay, so for example, let me write a path. Your application is writing a logs to this path, okay, to app/log/output.log, and this path only exists inside your container. Okay, but containers are not permanent. We know this. If a container crashes, restarts, or gets recreated, for example, for some reason this container crashed, we will lose the data which is stored inside this container. Apps/app/logs/output.log, we will lose the data. Okay, this happens because container storage is ephemeral as well. So ephemeral, I told you, it's temporary. So anything stored directly inside the container is usually lost when the container is recreated. Now, to solve this, Kubernetes provides something called volumes. Okay, a volume is like a separate storage area attached to a pod. So this is a pod. We have our two containers happily running, and even if the container inside the pod restarts, the data inside the volume can still remain. We have pod, suppose this pod A, and we have application container, we have volume. Okay, the container can write the files into the volume instead of writing inside its own temporary file system. Previously, in case 1, so this is case 1, for example, this is a container, there is a file path, it used to write here. When it was deleted, everything lost. Now it is not writing in the, this is backend. Now it is not writing inside the container, it is writing in a separate volume. Now what this solves? The crashing problem, the container crashing problem, it has resolved. When it crashed and we lost the data in case 1, now when it again crashed, again a new container has been created, we will still have the volume with us, so we can have it. Let's understand emptyDir, empty directory. Okay, the most basic volume type is empty directory. So this empty directory volume is created when the pod is started. Now the problem with this empty directory is we could able to survive in case 1 the container crash. We cannot survive the pod crash. What if the pod gets crashed or pod gets restarted? Okay, that's another issue we have never thought of. Okay, so when the pod gets deleted and recreated again, we will again lose our data, because this empty directory is also temporary and attached to pod, and pod is temporary. I hope you understand the problems. So sometimes we want the data to remain even if pod is deleted. For example, we have something to store MongoDB data files, or we have some uploaded images. We need them to be stored. We need documents to be stored. For those purposes, empty directory is not enough. We need permanent storage. For that, we have concept or Kubernetes concepts, persistent volumes. Okay, we will understand these persistent volumes and persistent volumes claims. These are two concepts that are for the permanent storage, and we will understand this in upcoming lectures. For now, you got the concept of pod storage. Now regarding the theory part, I think there are few more concepts that I need to tell you. One is init containers. Init containers are important because init containers are special containers that run before the main application starts. These are the special containers that run before the main application starts. Another key point is the main container or main application container will not start before all the init containers complete successfully. These are the two important key points that you should remember if somebody asks you what is an init containers. So, for example, we are waiting for a database to become available. That can be an init container. We are downloading some configuration files. We are creating directories. We run migration scripts. So those can be run as an init containers. Take an example where suppose your application depends on MySQL. If MySQL is not ready yet, your application may crash. So you can have MySQL as an init container. So init container has their own lifecycle. If init container, and again the very important, init containers start one by one. So init container 1 starts and completes, then init container 2 starts and completes, then the main container starts. Okay, if any init container fails, Kubernetes keeps retrying it until it succeeds. The main application container starts only if all the init containers are completed. If failed, then it will again retry. You got the scenario where you need MySQL to be started before your application gets starts. So you can have these init containers. Now, another concept is sidecar containers. So sidecar containers is an external helper container that runs alongside the main application container in the same pod. Okay, and the main application does the primary work. The sidecar container supports it. Okay, you may be thinking what kind of support you may need. So you can see something like both containers running at the same time. They share same pod IP. Also, both containers run at the same time. They share same pod IP. They share the same local host and same storage volume. Okay, a real world example could be a Node.js application writes logs into a shared folder. I told you, that we have a backend service writing logs to some other container or some other service, so it can run alongside with it. For monitoring or for logs, we can have a sidecar container, or some security scanning containers or configuration reload containers. We can have a sidecar container. So this much is sufficient for the theory part. Now we are going to deploy this application which I built way back. It's a backend Java application, and let's open VS Code. We have already created K8s practice folder. We are going to create pod, then inside that backend.yaml. So YAML should be the extension of the file. Then whenever somebody asks you to create some object of Kubernetes, whether it is a deployment, whether it is a service, anything, first thing then you need to write is API version, then go back, metadata, then your spec. These three things are mandatory, should be there. API version tells you that we are using Kubernetes core version v1. Okay, so I'm going to write here v1. After that we will write kind is going to tell what object of Kubernetes we are going to use. So kind is pod. Then comes the metadata. Inside metadata we will name our pod, which is going to be the name of pod, backend pod. Okay, then we are going to add labels, app, backend, service. So what we are doing here, labels helps identify the pod later. Okay, app, this is the label value for grouping and selecting pods. Then comes the spec section where we are going to write containers, and name is going to define the backend container, backend service containers. Then image should be the image that we are going to pull from the Docker Hub. So we have copied that, and let me paste it here. We don't know this Docker pull command, and we are good to go with this. Then we have to enable ports, container port 8080. So this much is sufficient for basic pod definition YAML file. In containers we have list of containers inside the pod, and this name is backend name of the container. Image is the image that we want to pull, and we have opened this port because our application is expected to run on the port 8080 inside the containers. Now we are going to save this. Once we save, I hope you have already installed Minikube by watching my tutorial. So we are already here. Let's go inside pod, and we have our backend YAML file. We are going to run the kubectl apply -f command inside. After that, backend.yaml. So this is going to create our pod. So we can check by command kubectl get pods, and we can see a pod is running and it is healthy. I can show you by deleting the pod, kubectl delete pod, then pod name, backend service pod. Okay, now the pod is being deleted. If I rename this to something else, for example news or anything else, you can see we are going to redeploy the same thing. And when we redeploy, we can check our pods. So container is creating. This is one status I told you. And again, if I hit, you can see we are getting error image pull. Okay, we can describe to see what is exactly the error. So kubectl describe and then pod name, pod backend service pod. So this is going to give you the description. So the status is waiting, reason image pullback off, the state is false. So you can see it is trying to pull the image from Docker Hub, but it has failed to pull the image. So you can see what kind of error you can get if you mistype any image name. So again, I'm going to delete this pod and let me just fix this. So this is one way of deployment. So instead of writing the whole YAML file, you can also do this. You can directly write the command kubectl run, then backend service. Then you have to mention the image which you want to pull and then open the port. This is going to do the exact same thing which we did. So pod is created. We can directly check the pod, get pods, and our pod is getting ready. You can see the pod is ready now. So usually when you don't define any namespace, we are going to learn about namespaces very soon, but it is going to be deployed in the default namespace. So kubectl get ns. So you can see there are multiple namespaces. So basically it's going to deploy your pod in the default namespace. So you can check how many pods are there in the default namespace by running the command kubectl get pods minus n default. Minus n is for the default namespace. So you can see only one backend pod is there which is running. So that's really good. We are going good. We can deploy another pod, kubectl, then run nginx pod. Then we are going to mention the image name nginx, and let's enable the port as well. Port equals to 80. So nginx is also created. Let's see the pods. So container is creating. You can see now it is in running state. Both the pods are running. One is nginx pod, one is backend service pod. Let's see the description of nginx pod. I told you each pod has their own IP addresses. So you can see the IP address of the nginx pod and successfully assign default nginx pod to minikube. So we're doing this activity in minikube. So if you have not installed the minikube, you can definitely go and watch my video on installing minikube setup on Mac OS. And let's see what else we can do here. We can expose the port using port forward pod nginx pod 8080 to 80, and then we can hit enter. So what it is going to do, if we go to browser again and if we go to port 8080, we can able to see the nginx page. Welcome to nginx. So it's working. Now we can stop this. I hope the pods are very clear to you. In the next upcoming videos, we are going to see namespaces, services, and deployment. A lot of other important components that we need to look into it. And please subscribe to Technicos.